In this example, I'm going to use synthetic division to divide this polynomial, which contains both rational and irrational coefficients, by this linear binomial x plus 2 minus 3, which also contains a rational and an irrational number. So remember, this divisor, in order to use synthetic division, needs to be in the form x minus k. Well, it looks like we kind of have this rational and irrational number combination that's going to make up our k. So if I write this in the form I want, I'll end up with minus 2 plus the square root of 3. So x minus, so then this value here is my k. Maybe you don't like leading with a negative, so you can flip those around and say k equals the square root of 3 minus 2, and that would be okay. So we can go ahead and start right there. My value of k is the square root of 3 minus 2. So let's go ahead and write that out here. The square root of 3 minus 2. Okay, and so here's my synthetic division. And I'm focused on grabbing these coefficients, and I'm going to put them in here in columns. So for my cubic term, x cubed, I have a 3. For my quadratic term, I have 13 minus 3 radical 3. For my linear term, I have 13 minus 7 radical 3. And finally, my constant is radical 3 minus 2. And I'll put my little box down here for my remainder, if I happen to have one. So let's go ahead and work this. I'm going to bring down my leading coefficient here, which is 3. And then I'm going to do my series of multiplications and additions on these columns. So this will be 3 times the square root of 3, which is 3 radical 3, and he's positive, times the negative 2 in the 3 makes a negative 6. So when I add this column, the 3 radical 3 terms cancel, and 13 minus 6 is going to be 7. Okay, so let's go through my multiplication again. The square root of 3 times 7 is positive 7 square roots of 3, and then negative 2 times 7 is negative 14. So we see again the square roots of 3 cancel, and 13 minus 14 is negative 1. So my final multiplication will give me negative square root of 3 plus 2, and these cancel, and I'm left with 0 for a remainder. So lots of cancellations throughout here. So to build this back up, I have my constant, my linear, and my quadratic terms. So I'll have 3x squared plus 7x minus 1 with no remainder. So here's the polynomial I get when I use synthetic division to divide this original polynomial by this linear binomial, and all of these have both rational and irrational numbers kind of running all over the place, so not too bad of a problem.